Good morning, guys. It's Miss Davenport. As requested, we are going to make our writing a little bit bigger today. Yay. And to kind of get you guys pumped up for conduction, convection, radiation, we're going to have an intro song. Okay? So if you remember, we listened to this one in class. It's a really good tool to know that it always goes from hot to cold. And today we're going to look at that a little bit more, have some real life examples from my kitchen. All right?
From hot to cold. From hot to cold. Heat transfer goes from hot to cold, from hot to cold, from hot to cold, from hot to cold, from hot to cold. Heat transfer goes from hot to cold, from hot to cold, from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold. You'll always remember this, kiddies, even when you're getting old. When you go out to dinner, you want food that is super real hot. But if you wait too long to eat, oh, you'll be so sad with what you got. See what happens, it's really easy. The food is sitting out and touching the air. The heat from your food's not disappearing, it's being transferred to the air. Cause heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Summertime and you're at the pool, jumping off the high dive. Once you hit that cool water, it feels like you're frozen alive. See what happens, it's really simple. Your body has a warmer temperature, cause once you touch that cooler water, it's taking your heat energy for sure. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Thermometer is a tool we use to measure heat energy. It measures particles' movement. They're moving endlessly. When molecules gain heat energy, they move around faster. The liquid expands and the temp goes up on the thermometer. Cause heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Grab some different objects sitting in your room at home. Some feel cooler while others are warmer, but they have the same temperature. So the reason is that some objects conduct energy better than others, meaning it takes energy easily. We call these things conductors. The objects that are warmer, we call these insulators. They don't conduct energy that well, so I'll see y'all later. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold.
All right. So I hope that got us in the spirit, got me in the spirit. So let's look at three quick recap notes. Conduction, convection, and radiation. Okay? So remember, number 1, conduction. Conduction is, and you should be able to say it in your head, the transfer of heat by direct contact. Okay? So that means that I've got two objects touching. Alright? So for instance, my burner and what sits on top of my burner? My pot. Okay? Now remember, we go from hot to cold always. And that simply means that in order to heat my pan up, I have got to sit it where? On my burner, right? Because I can't just sit my pot somewhere and it heat up. It's cold. I've got to sit it on the hot, my source of energy, and it goes from hot here to the cold, to my pan, which is how I heat up my water to heat up my noodles, okay? Hot to cold, always, always, always. All right. Just a quick side note, where does this usually happen? Conduction usually happens with what? What state of matter? Solids, okay? So if you're getting tripped up, if you're getting confused, look and see if the question's asking you about a solid, liquid, gas. We can narrow it down, okay? All right. Second heat transfer method, convection. What is convection? So this is the transfer of heat by what? So you can either have warm air doing what? Rising. And cool air sinking. Or by warm water rising and cool water sinking. Okay? And if you remember this guy right here, remember what two phases of matter does this occur? So you should have said to yourself, this occurs in either a liquid or a gas, okay? So same goes for convection. If I have a question, I'm getting stuck on it, does it talk about a liquid or gas? Bam, I should be able to directly relate that to convection, okay? All right, our last but not least is what? Radiation. So number 3, radiation. Radiation, and radiation is the transfer of heat through what? That crazy word, electromagnetic waves, okay? And one of our main examples for this is sunshine, okay? So maybe this weekend you were outside, you got a little bit too much sun. That means you've got a little bit too much radiation. That heat was traveling through. These electromagnetic waves came down and has given you a nice suntan, okay? So make sure you've got all those notes down. This should be going in the next empty page of your interactive notebook, okay? And so what we're going to do next is we're going to look at a few hands-on examples of conduction, convection, radiation, okay? So I'm going to see if this will turn. Oop, there's my stove. See what the best way to do this is. Completely upside down, isn't it? All right, well, we'll just put it like this. All right, there's one of my burners. Hey, burner. And what we're going to do is we're going to have some examples of conduction, convection, and radiation here, okay? So if you tell, I've also got my stove. I'm going to go ahead and cut my stove on, let's see, 400 degrees Fahrenheit. So let's start cooking that, or heating it up anyways. Now, if I open my oven up right now, bam, there's the inside of it. It's pretty cool right now, right? So when I close this door and I open it back up in about 5 minutes, it's going to be what? It's going to be hot. I better watch my fingers. And the reason that's happening is why? Anybody? So I've got convection, which is making the cool air rise, the warm air rise, the cool air sink, right? And when I open my oven up, I can actually feel that heat through what? Radiation, through those electromagnetic waves, okay? So what I'm going to do is I'm going to take my pan right here. I'm going to get some nice little crescent rolls out. Oops. See if y'all can see that. Some crescent rolls. And open them. This part always scares me because the thing pops. And I know it's going to pop, but it still scares me. So I might scream. Woo! There we go. Alright. So I'm going to grab my non-stick spray. Spray it down real good. When I have to clean up a big mess afterwards. Then I'm going to take my crescent rolls and I'm going to separate them out. Alright. So I'm going to take it, I'm going to roll it up. I'm going to have that nice fluffy crescent roll in just a minute. Yum. Don't start drooling. I know y'all are going to get hungry after this. You'll be all right. It's almost lunchtime. A few hours. All right, we're going to roll that one up. Now, as we talk about this, I want you to think about the heat transfers that are about to happen. Okay, because there's more than one of them. It's not just one that's going on. It's more than one. So in my oven right now, I've got that warm air rising, that cool air sinking to give me a nice even temperature throughout the entire oven, right? Because I don't want to have to stick these on my pan and the air that or the rack that they're sitting on in that area not be warm. Okay? So I've got to have convection to heat my entire oven up properly. Remember, when it reaches that point where it's the same temperature throughout, it's called what? Equilibrium. Okay? Now, when I put this in the oven, if you notice when I open the oven, there's a rack in there, right? And it's metal. And we're going to start talking about good conductors and good insulators. Bad conductors and bad insulators. A good conductor is something that really absorbs that heat energy. It really looks for that heat. Okay? And it takes it in, and it's got really good properties of keeping things warm. Metal is an awesome, awesome, awesome conductor. So that's why you notice in your ovens, the pan that you sit stuff on is metal. Okay? So if I look right here, am I about to put this in a cold environment, my oven, or a warm environment? My oven's going to be very warm. This guy is cold, right? They just came out of the refrigerator, they're cold. So my heat transfer is going to happen from hot inside of the oven to cold when I put these guys in, and it's going to transfer that heat to cook my little biscuits here, okay? All right, now, when I put this pan in the oven, is the pan going to get hot? Yes, that is why I have my little mittens right here, so I can get it out of the oven without scorching my fingertips off, right? Because that wouldn't be good. So what's happening here? Do I have two solids here? Well, I know my Pillsbury is a solid, and I know my pan is a solid. Two solids direct contact is what kind of heat transfer? Conduction. Yes, yes. All right. So we are going to put this in my oven. Okay. Bam. You heard it hit that metal rack. Metal's a good what? Conductor. Yes. All right. Next thing. I've got my pot right here, okay? I'm going to take this pot and see if you can see over here. I'm going to fill it up with water, okay? Right out of my faucet. what do you think we're about to demonstrate here? There's only 3 states that matter. Solids deal with conduction. What do you think liquids and gases deal with? Yes, convection. So I'm going to cut my knob on high. We're about to turn this up in here. These gas molecules are about to get hot. Okay, they're about to start moving crazy. And while we wait for that, I am going to do another demonstration. Okay? What do I have here? It is an egg. Okay? So I'm going to take this egg and break it, crack it, and I'm going to cook it. Okay? And I want you to tell me what kind of heat transfer you're getting from here, okay? So I'm going to cut the burner on. Just cut it on. And first and foremost, what kind of heat transfer is putting... Whoop, that's getting hot. I better not touch it. What kind of heat transfer is putting the pan on the burner? I've got a solid. I've got a solid. That makes what? Conduction. Very, very good. Same thing back there. I've got solid, solid. These two guys make up conduction. It's going to transfer heat. If you look really closely, you can see my water starting to get bubbles in it. That means that the hot water from the bottom is rising. The cold water is coming to the top. And it's going in a continuous cycle. Remember those arrows that we draw to represent convection. Now, as I stand here, and I know you guys can't feel it, but I want you to use your imagination. As I stand here, let's say I take this pot off, right? I put my hands right here. I can feel heat, okay? I mean, it's hot. I can feel that it's on. What does that represent? So kind of think about an open fire. Think about this being an open fire. Think about me having a stick with marshmallow on it. And I'm not touching it. I'm just using the heat, feeling heat from around it. Okay? Now keep in mind, this is not a liquid or a gas. It's a solid. But unless I touch it with another solid, which is my finger, aka I'm not crazy enough to do that because that's going to be hot. What kind of heat transfer is this? It's radiation, right? It's heat traveling through these electromagnetic waves. All right. So conduction, pan burner. Take my egg, crack it. What kind of heat transfer is going to happen between the egg and the pot and the pan? The egg and the pan. You see it start to turn white. Is my heat moving from the egg to the pan or from the pan to the egg? It's moving from the pan to the egg. From hot, my pan's really hot, to my cold egg. Always. Okay? Remember, heat transfer is really neat. It always moves from hot to cold, from hot to cold, from hot to cold. Okay? And so we'll just cook my egg. Let me grab a spatula. How did my fire alarm know that it was getting a little too hot in here? Radiation! Woo! Alright, so you see my egg cooking, right? And still moving from hot to what? Hot to cold. The heat is cooking the egg. The egg is cold, pan is hot. Cooking my egg. Add a little salt. Add a little pepper. Conduction at its finest. Me cooking some eggs. Direct heat contact. I gotta have mine scrambled. I can't be eating that juicy stuff where it's coming out all nasty, yellowy, yolky. So my egg looks pretty good. Let's check on my crescent rolls. Woo! I just felt a blast of heat. What kind of heat was that? Oh, there it goes again. You can tell that radiation is occurring how? Because my fire alarm's picking up on it. Alright, let's look back here. What's happening to my water? So a minute ago I was able to put my finger in and touch it. Do you think I'm going to have the same look without it being super hot? Definitely not. Okay, you see those bubbles down there? If you look really closely, look on the side right there. You're going to see these bubbles rise and come to the top. Let's see if we can find one. Oh, you saw that bubble? Maybe that won't happen again. But you see those bubbles coming to the top and rising? That is convection. That's convection happening right before your eyes. Okay? That hot air's coming up, the cool air's going back to the bottom to make my water one complete temperature, which means it's going to reach what point? Equilibrium. I'll definitely never catch on fire without my fire alarm going off. Me not doing it. Alright guys, so I hope this helps. You've got some guided notes you're going to do with this. You should be doing them throughout. If not, you need to make sure you're completing them. I'm going to go eat me some eggs, biscuits, and I might cook me some noodles. And this is conduction, convection, radiation at its finest. Alright?